And boom, Jenkins back. We are going to go through every single equation that's on the equation review. We're going to apply it to some problems. These are the same type of problems on the quick check. If you can do them right now, you can do them on the quick check. Stop this video at any time, go back and do these on the follow along notes that's right above this video, or if you're in class, you have them. So let's start. Equation number 1. If I looked at the equation sheet, equation number 1 says acceleration is the change in velocity over the change in time. So that's my first equation, the change in velocity over change in time. Acceleration is change in velocity over change in time. And Jacorian, make sure you can get that right there. Everyone see that? Acceleration is change in velocity over change in time. Now, if you do not know where to find those, look at the agenda under the equation review. It's the very first one. You'll have it on quizzes. You'll have it on tests. You'll have it on the ACP. You have it now here. Let's look at the question. It's so easy. And you might need your phone too. A car is going 5 meters a second, and it speeds up to 15 meters a second over the span of 5 seconds. Look what I just did. I circled all this stuff that it gives me, given. What is the car's acceleration? That's my unknown, that double underline. I do not know it. Given. 5, 15, 5. Let's go. 5 meters per second, it's going. I'm going to draw a little diagram. So my car is going 5 meters a second, and it speeds up to 15 meters per second, right? So this is how fast it's going after how many seconds go by? 5 seconds. 5 seconds. So 5 seconds go by. Can I put this into my equation and find out what the acceleration is? Absolutely I can, right? Because acceleration is just how much velocity changes over how much time changes. The ratio between changing velocity and changing time. Changing velocity and changing time. This is also my final minus my initial over time. Now all I have to do is plug this in. What is my initial velocity? What did I start at? Can anyone tell me what what is my final velocity rather? What is my final velocity? What did I end up at? 15. 15 minus, look what I'm doing. I'm just plugging them in. 15 minus, what is my initial velocity? What did I start at? 5. 15 minus 5 over time. How much time changed? 5 seconds. 15 minus 5 divided by 5. Why is there a negative right there? 15 minus 5 divided by 5. 15 minus 5 is what? 10 divided by 5 is what? 2. My units, meters per second squared. It's that dang easy, y'all. See what I'm talking about? The ratio of how much it changes divided by how much time changes. How much velocity changes versus how much time changes. It's like that. Every single question is going to be this easy if you just follow the same procedure. Now, let's make it a little bit harder. We have that's not the only equation. What if Jacorian's out there, he's running around. I know his initial velocity, I know his final velocity, but my stopwatch broke. I could not time him, but I knew how far he went. Could I use a kinematic equation to determine his acceleration? The answer is yes. The answer is absolutely yes. It's the second of your kinematic equations involving acceleration, and it looks like this. Acceleration is final minus initial, just like you always know, except these are squared, divided by 2 times the distance. I told you that you didn't have time. You're going to have to use the displacement, and you can do that. Let's go. A car going 5... Let me move to 2. There we go. We're on 2, equation 2. And this corresponds with the second equation on your equation sheet. The car with an initial velocity of 4 meters a second, I'm going to circle it, accelerates to 6 meters a second. When it does this, it travels 5 meters. It goes 5 meters. Find acceleration. Underline my unknown. I'm looking for acceleration A. What do I have? Initial velocity. I have V sub I. It accelerates to 6 meters a second. I start at 4. Here's my car. I start at 4 meters a second. I accelerate to 6 meters a second. After how many seconds? I don't know. I don't know how many seconds, but it tells me this distance, this entire distance is 5 meters. Is there a way that I can use this equation to find out the acceleration? Absolutely. Do I know my final velocity? Yes, I do. Do I know my initial velocity? Yes, I do. Do I know my distance? Yes, I do. Is this going to be a positive or a negative acceleration? Just reading the question, you can know. Positive. Positive. It speeds up, right? It speeds up. It starts from 4, ends up at 6. It's going to be a positive. I don't know how to do this yet. All I have to do is plug and play. Let's go. It's like this, y'all. What is I'm looking for acceleration. That's my unknown. What is my final velocity? 6. Do you understand how it's not 4? I started at 4. I ended up at 6. Going to 4 to 6, that's a positive change. So I got 6, and don't forget this, squared minus, what is my initial? 4 squared divided by 2 times the displacement. How much displacement? 5 meters. 5 meters. Now let's go. Quite easy after this, elementary even. You could plug this into Mathway. You could do InSolve menu 3-1, right? X is equal to 6 squared minus 4 squared divided by 2 times 5. You don't even need to use InSolve. Just type this in. What's 6 times 6? 36. Minus what is 4 times 4? 16. What is 2 times 5? 10. 36 minus 16 divided by 10. Guess what it is? What is 36 minus 16? 20. What is 20 divided by 10? 2. Dos. 2 meters a second squared. Acceleration is 2 meters per second squared. It's like that. It's so easy. Now, how did I know to pick this equation? Because I'm the teacher, I know. How are you going to know to pick the equation? Exactly. What do I have? What's given? I have initial velocity. I have final velocity. I have distance. I have to find acceleration. Which one of these has acceleration, final, initial, and distance? This one. Why can't I use your big brain and tell me this. Why can I not use this? Someone tell me why I cannot use this. Tell me why I can't use that. Why is that a no-go? No tiempo. Lo siento. It's not there. How are you going to use that? You can't do it, right? It gets harder. You ready? Let's go to equation number 2, hard style. What if I say a car is accelerating at 3 meters per second squared? Immediately, bells should be going off. Accelerating at 3 meters per second squared? It just gave me acceleration. How is it going to give me acceleration when I've been trying to find acceleration? Obviously, I'm not going to be solving for acceleration. I'm going to be finding something else. So a car is accelerating at 3 meters per second squared. So it's got an initial velocity, and it's going to go, and it's going to have a final velocity, because that's how acceleration works. Delta V. This is the change, right? And it goes a distance of 12 meters. So again, the distance is 12 meters. Whew, bros. Let's go. A car is accelerating at 3 meters a second squared. Find its final velocity. Oh, here's my underlines. Final velocity if it began at 6 meters per second and traveled a distance of 12 meters. What do I know here? What is my initial velocity? Correct, 6. What is my final velocity? Do I know it? No. I do not know it. I do not know it. What else do I know? Do I know my time? No. I do not know. Where's my time? We have distance. We do not know. We have distance. We have distance and it's 12. Let's go. Look how I can use this equation. Acceleration is final squared minus initial squared over 2 times the distance. I can use that. I can use that. Let's go. So, what I'm going to do is I'm going to plug and play, except this time, the equation, when I fill it in, I'm going to be filling in on both sides of the equation. What is my acceleration? Do I know it? 3. 3 equals, what is my final velocity? Do I know it? I do not know it. So that squared minus, what is initial velocity? 6. No. Oh, you're right, 6. 6 squared divided by 2 times, what is the displacement? 12. 12, let's go. That's a math problem right there. I'm looking for the blue. You know what I'm saying? This is easy. Mathway, menu 3-1. 3 is equal to x squared minus 6 squared over 2 times 12 comma x. Solve for x. Let's go. Anything. Me, I'm like this. 3 times 12, or 2 times 12, what? 24, right? This is 24. That's 24. Multiply both sides by 24. Let's go. You're gone. 24 times 3. Anyone know that? Anyone know 24 times 3? Someone hook it up. 72. This is 72. So this becomes 72. This goes away. Yeah, it's like that. 72 is equal to final velocity squared minus 6 squared. What is 6 squared? 36. Let's go. How do I get 36 over here? I add 36. It's like that. It's so easy. I add 36 over here. This goes away. What's 72 plus 36? 6, 7, 8, 10, 108, right? That's 108, right? 108. 108. 108 is equal to this number squared. How do I get this number? What's the opposite of squaring? Square root. If I root this, that goes away. I got to root that. The final velocity is equal to the root of 108, which is some number. What is it? Anyone know? It's like that. So we can do this with our calculator. We can do this with our phone. We can do this with anything in Google. We can find these out, all right? It's all about what equation we use. I'm not trying to sit here and test you if you know the root of 108. You know what I'm saying? 10 point what? 10.39. Or 10.4. We're going to say 10.4 meters per second. 10.4 meters per second. This, look at this. If you were to step back and show this to your neighbor, your friend, your mom, whatever, they'd be like, "Are you Albert freaking Einstein?" But look, it's actually it's that easy. I'm telling you. It's that easy. This basic kinematics is that easy. Let's bump it up. Let's kick it up a notch. You know what I'm saying? Let's make it spicier. How about this one? We're on equation 2, hardest version of the equation. Why is it hard? Because I know at least 3 of you and like 10 of you at home are going to make this mistake because you didn't listen the first week when I said acceleration, velocity, these are all vectors. They have a direction, and direction matters. Let's go. A car slows from 40 to 22. Someone stop me and tell me what you know about this already. Deceleration. Okay. So when I translate that into numbers, are you gonna screw that up? Are you gonna tell me something that's not true? Or are you gonna be on top of this? A car slows from 40 to 22. It's going 40 meters per second, and then it slows to 22 meters per second. And it does it over a distance of 3 meters. And the distance is equal to 3 meters. Find acceleration. Okay. What equation do I use? Well, it didn't change. It's still a second one. Can I use this one? Let's tell me why I can't use this one. Acceleration is my final velocity minus my initial velocity over time. ¿Por qué no? No time. I have distance. I have no time. Come on now. We don't have time for this. We got to square those, and it's 2 times the displacement. Oh, shit. I didn't mean to do that. We'll just start again. Let's go. So I have my formula that I know I'm going to use. My acceleration is the square of my final minus the square of my initial. Velocity is over 2 times the displacement. It doesn't take Einstein. It just takes a formula. Let's go. Find the acceleration. I've got 40, 22 velocities. I got 3 distance. Find acceleration. A is equal to. And this is where you're going to mess up. What's the final velocity?
22. Final is 22.
Oh, nice. Okay, someone did it.
That was the star.
Someone did it. See what you did wrong? Villegas is super smart, but even I will do it all the time. Y'all will have to correct me sometimes. Because it comes first in the problem. And you're like, if you start at 40 and you go 22, you want to say that the final velocity is 40 because it's bigger. It's not. The final velocity is 22. 22 minus 40. That's the change. Tell me what happens when 22 subtract 40. What are you going to get? A negative number. Why does the negative number matter? What does that tell you?
Deceleration.
It tells you the opposite. It's decelerating that way. What is 22 minus 40?
You don't have to square it?
Oh yeah, shit, we do have to square it. Okay, correct. You do have to square it. Let's do that. 22 squared minus 40 squared over 2 times 3. I don't want to do that. I know you know how to do it. Let's do it together. Someone bust out their calculator. What's 22 squared?
40, negative 40.
So the whole thing? What is 22 squared? 22 times 22.
Yeah.
Huh?
Negative 44.
22 squared isn't a negative number.
484.
484? 484 minus, what is 40 squared?
1,600.
1,600? What if I subtract those, what do I get? And then divide by 2 times 3 is 6. 484 minus 1,600 divided by 6. That's what's up. 484 minus 1600 divided by 6. There you go. See, I can even mess up the equations. I'm going fast. Always refer back to your equation. What is it? 44 minus 1600 divided by 6.
Negative 1,116.
Yeah. 1168?
Negative 1,116.
Negative 1116 meters per second. Yes. This is how you can find this stuff. It's that easy. It's that easy. Now, this is what I wanted to show you is that deceleration. Going from 40 to 22, you have to see that I need to put my final minus my initial, or if you flip that, you're just going to get a positive number. And that's wrong, because that doesn't show acceleration, deceleration. It shows acceleration. What's up, Viegas?
So what do we divide it by sometimes
You need to divide it by 6. All right, more practice later. I just wanted you to see the difference between speeding up and slowing down, because I want to get y'all out of here at a decent time, and I want you to work on your characters. Let's go, last one. There's one more formula. If you did not check the equation sheet already, I got you. Now, this is a different type of problem. It says a car going 5 meters per second accelerates at a rate of 2 meters per second squared over a time of 10 seconds. How far did the car go? Yes?
I think the other one is 217.3.
That's, yeah, I'm not going to check it right now. We'll work it. We'll come back and work it. Let's do this real quick so we can get the video. We'll come back to it. So look at this one. Equation 3 says a car is going 5 meters a second, constant, and then it starts accelerating at a rate of 2 meters per second squared over a time of 10 seconds. How far did it go? Now, can I use this equation? Acceleration is final velocity minus initial velocity over time. Can I use this? Do I have acceleration?
Yeah.
There it goes. There's acceleration. Accelerates a car going 5 meters a second. What's that? It's going 5 meters a second. Then so that's my initial. V initial. Time T. Yeah, I got it. Can I use this?
Yeah.
What am I looking for?
You're looking for the final.
I'm looking for the distance, bro. Can I use this? I can't. I got you. There's another one. Acceleration is final squared minus initial squared over 2 times done. I got this, right? Easy. What is my acceleration? 2. There's my acceleration. What's my final velocity? Oh crap. Oh crap.
Would that equal 25 meters per second?
Ah, so we can do that in our heads. We have an equation, right? If we want to find how far something goes, and all we do know is how fast it's going when it starts, and when it starts accelerating. This is my final equation. This is the last equation that you're going to use. And it goes like this. The displacement is going to be equal to my initial velocity times time plus 1/2 acceleration times time squared. Now, I'm going to give you a second to just freak out collectively, because you're going to be like, there's no way. There ain't no way. It's just like the other ones. It's so easy. It's plug and play. What this says is how far I go is equal to my starting velocity times the time. That's going to be a number. Plus how much I accelerate. And there's just some numbers. So there's half and then squared. All I have to do is input this. All I have to do is plug it in. If I want to find the distance, how far? And I have the initial velocity. Let's do this. Distance is equal to, what is the initial velocity? What is my starting velocity? 5. How much time did I go? 10 seconds. 5 times 10. Y'all see that? 5 times 10 plus 1/2 times acceleration. What's acceleration?
2.
Dos. What's time?
10.
Same stuff, 10. Squared. That's it. That's it. 10 squared. What is 10 squared? 10 times 10 is 100. Times 2 is 200. Divided by 2 is 100. Plus 5 times 10 is 50. It's like that. Someone get that for me. Calculate that. 5 times 10 is 50. And this you can do in your head. 10 squared is 100 times 2 is 200 divided by 2 is 100. Right? That's 100, right?
Yeah, it's 150.
Basic. So the distance is 150 what? Meters. It's like that. It's so easy. It's so easy. How did I know to pick this one? Depends on what I had, like Nick said. It depends on what I have, right? Here it gives me initial velocity, v sub I. It gives me acceleration, a. It gives me time, t. And it's asking for d. There's only one equation that has initial velocity, acceleration, time, and distance. If I have the time and the distance, I can find my final velocity, right? If I have the initial velocity, I can find the distance. You just have to pick the right equation.
That 150?
Yeah, it's 150, right? You tell me. 10 squared, that's 100. Times 2, 200. Divided by 2, that's 100. Plus 100 plus 5 times 10 is 50. 100 plus 50, 150 meters. It's like that. It's so easy. It's so easy. Yeah. All right. This and nothing more. This right here is as hard as it gets. If you can do these, you can do literally anything that is on this 9 weeks test. Anything. I'm telling you right now. And I'll give you practice, right? On your quick checks, or excuse me, on your catalysts, I'll give you all the formulas. We'll work them every single week. And you will be fine, I promise you. All right. Gut video.